Howdy and welcome back. So I guess the last video took a bit longer than I expected. It definitely felt like 20 minutes. I didn't realize it was, but I'm going to go ahead and just push forward. I know this lesson today might have been a bit longer than expected, and I'll try to make up the time for it at some point with the idea of hopefully a lesson or two later this week that's not as crunched in terms of duration. So the rule of zero and the rule of three. This will be short, I promise. So the rule of zero. So by default, the C++ compiler is going to provide us default operations with their default semantics. The compiler generated copy constructor and copy assignment operator are going to implement a member-wise copy. And we saw this at the beginning of today's lesson, as well as within the previous lesson. Now, the default constructor is simply going to be deleted. If you don't need one, the compiler's not necessarily going to provide a definition of it. But for all intents and purposes, if you're kind of going, I don't get how that happens, just think about the default constructor as something blank. It doesn't really do anything. Its function body is left empty. So here's the rule of zero. If you can avoid defining the default operations, so copy constructor, copy assignment operator, or the constructor, in this case, you should go ahead and do so, in the sense that don't define them unless you have a reason to do so. This is known as the rule of zero. So if there's no reason to have any one of them, you don't need any of them. Now, the rule of three, this has kind of been around up to C++11. Thereafter, it's transformed into the rule of five, which has come to include move semantics. If we cover move semantics in this class, it won't be until a bit later. So we'll use the rule of three until we have reason to do so otherwise. So the rule of three is a rule of thumb in C++. If you define a copy constructor, a copy assignment operator, or a destructor, then you probably should implement the other two as well. So they kind of go together. If you have a destructor defined, implement copy constructor and copy assignment operator. If you've defined the copy assignment operator, well, define the copy constructor and destructor too. And then since we've gone through it all so far, if you define a copy constructor, define the copy assignment operator and destructor. The reason you defined one of these functions was likely to expand, change, or avoid the default behavior. Therefore, if you'd like something else to happen, such as a deep copy, you need to implement that behavior or accommodate that behavior across all of these functions.